Chapter 2.2, Trigonometric Ratios of any angle. Let's look at angles in each of the quadrants, starting with quadrant 1. We have an angle in quadrant 1, and it goes through a point that is xy. We can create a right triangle by drawing a dotted line straight down from our point. That would be the y value. The vertical distance to the point is the y value, and then the bottom line of the triangle would be the x value, and we have a right angle in that corner. That would make the arm of our angle the hypotenuse. The angle of elevation is theta, which in quadrant 1 is also the reference angle, so it's also theta r. The sign of x and y in quadrant 1 is positive. X values are positive and y values are positive in quadrant 1. If we look at the trig functions then, we have sine theta equals opposite over hypotenuse. From our angle theta, or the reference angle, theta r, the y is the opposite and the x is the adjacent. Then sine equals opposite over hypotenuse would be sine equals the y value over the hypotenuse. The y value is positive in quadrant 1. The hypotenuse is always positive because of the way that it's made by squaring y and squaring x and then adding them together. So we would get positive. So sine of any angle in quadrant 1 is going to be a positive. Let's look at cos. Cos of an angle in quadrant 1, adjacent over hypotenuse, we have x, which is positive, over the hypotenuse, which is always positive, and that would give us a positive value. And then tan theta in quadrant 1, opposite over adjacent, so that's y, which is positive, over the adjacent is x, which is positive in quadrant 1. So we get a positive over a positive, which gives us a positive. So in quadrant 1, we can say all our trig functions are positive. Let's do that same process for quadrant 2. We have an angle in quadrant 2, goes through a point which is negative x, y. Because it's to the left on the x-axis, it's negative, but it's still above the x-axis, so it's a positive y value. We can create a right triangle by drawing straight down. This would be our y value, the vertical distance to that point, and then the horizontal distance would be our x value. The y value is positive in this quadrant, and the x value is negative. Our theta, standard position, remember this would be theta, and this angle here would be theta r. And then we have our hypotenuse, which again is always going to be positive. Let's look at our trig functions. Sine of an angle in quadrant 2, opposite over hypotenuse. Opposite would be the y value, adjacent is the x value, so sine would be y, which is positive, over the hypotenuse, which is positive. Positive over positive gives us a positive. Cos of an angle in quadrant 2 would be adjacent over hypotenuse. So x, which is negative, over the hypotenuse, which is positive. A negative divided by a positive gives us a negative. And then tan theta, tan of an angle in quadrant 2, opposite over adjacent. Opposite is y, which is positive, over adjacent, which is x, and negative. Positive divided by negative gives us a negative. The trig function that is positive in quadrant 2 is sine. Quadrant 3, same thing. Let's look at an angle in quadrant 3. Our point that our terminal arm goes through would be negative x, negative y in quadrant 3. We can draw our right triangle going up to the x-axis. That would be our y value, the vertical distance, and it would be negative in this case. And then our x value is the horizontal distance. That would be also a negative in this case. Then we have our hypotenuse, which is always positive. Our angle, theta, is there. And our reference angle, theta r, is here. Sine of an angle in quadrant 3 is opposite over hypotenuse. Opposite is our y value. Adjacent is our x value. We have y, which is negative, over the hypotenuse, which is always positive. Negative divided by positive is a negative. Cos of an angle in quadrant 3 is adjacent, which is x, which is negative here, over hypotenuse, which is positive. Negative divided by positive is a negative. And then tan of an angle in quadrant 3, opposite over adjacent, so y, which is negative, over x, which is also negative. Negative divided by negative is a positive. So in quadrant 3, the trig function that's positive is tan. And last quadrant, our point that our terminal arm goes through would be positive x, negative y in this quadrant. We draw our right triangle. The vertical distance is the y, which is negative, and the horizontal distance is the x, which is positive here. Then we have our hypotenuse, which is always positive. Our angle, theta, is there, and then theta r is there. Looking at our trig functions, let's label from theta r. Y is opposite, and x would be adjacent. Sine of an angle in quadrant 4 equals opposite over hypotenuse, so y, which is negative, over the hypotenuse, which is always positive. Negative divided by positive gives us a negative. Cos of an angle in quadrant 4 is adjacent over hypotenuse, so x, which is a positive, over the hypotenuse, which is always a positive, which gives us a positive. And then tan of an angle in quadrant 4 is opposite over adjacent, y, which is negative, over x, which is positive. Negative divided by positive is a negative. So in quadrant 4, cos is the trig function that's positive. This is called the cast rule, and you need to know this along with knowing the two special triangles. In quadrant 1, all trig functions are positive. In quadrant 2, sine is positive, the others are negative. In quadrant 3, tan is positive, the others are negative. And in quadrant 4, cosine is positive, and the others are negative. So let's put what we've learned into action here. The point P, -5, -12, lies on the terminal arm of an angle theta in standard position. Determine the exact trig ratios for sine theta, cos theta, and tan theta. Let's start by drawing a picture. -5 is approximately here. Let's say -12 is here. Then our point -5, -12 is about there. And the terminal arm we have our right angle. The x value is -5, the y value is -12. Theta r is here. Theta, it would be that angle. And then the hypotenuse, which we can calculate by using Pythagorean theorem. A squared plus b squared equals c squared, which is the hypotenuse. -5 squared plus -12 squared equals h squared. 5 squared is 25. 12 squared is 144 equals h squared. 25 plus 144 is 169. We want h, not h squared, so we square root both sides. Then h equals the square root of 169 is 13. Then sine theta equals opposite over hypotenuse. Opposite is our y value, and adjacent is our x value. So sine theta equals opposite, which is -12, over the hypotenuse, which is 13. Cos theta equals adjacent over hypotenuse. Adjacent is -5 here, hypotenuse is 13, so -5 over 13. And tan theta equals opposite over adjacent, which is -12 over -5, 12 over 5. Next example, determine the exact value of and cos 240. Let's start by drawing our angle. (240) is between 180 degrees and 270 degrees, so it's in quadrant 3, and it's closer to 270 than it is 180. Something like this. Then our angle from standard position is here, which is 240 degrees, and our reference angle theta r is here. And let's figure out what theta r is. We're in quadrant 3, so we want to take our angle theta and subtract 180 degrees. Theta r equals 240 degrees minus 180 degrees. So theta r is 60 degrees in this case. So if we have a reference angle that is 30 degrees or 45 degrees or 60 degrees, we need to think of our I'm going to draw my 30, 60, 90 special triangle. We have a 90-degree angle, 60-degree angle, and a 30-degree angle. The hypotenuse is 2, the side adjacent to 60 is 1, and the side adjacent to 30 is 3. Our reference angle in this question is 60 degrees, so we're looking from that angle in our special triangle. Label our sides. Root 3 would be opposite, and 1 would be adjacent. And then we're interested in sine of 240 and cos of 240. So we're going to start with sine of the reference angle, sine of theta r, which is sine of 60 degrees, equals opposite over hypotenuse. Opposite in this case is root 3, hypotenuse is 2, and then cos theta r, cos of the reference angle, which is cos of 60 degrees, is adjacent over hypotenuse, which in this case is 1 over 2. Then we need to apply the cast rule. C-A-S-T, so starting in the bottom right, C, then up, A, then left, S, and then down T. This tells us which trig function is positive in which quadrant. So in this case, when we did sine of theta r, that's sine of 60, that's in quadrant 1. 60 degrees is in quadrant 1. Our angle is in quadrant 3, so after we calculate the value of sine 60, then we have to think about the cast rule and look at which quadrant we are in. So we are in quadrant 3, which is here. In quadrant 3, tan is the only trig function that's positive, which means sine and cos are negative. So then, quadrant 3, sine of 240 degrees would equal negative square root 3 over 2. So the value is the same, but the sign is different. Same with cos. In quadrant 3, cos is negative, so cos of 240 degrees is negative 1/2. Suppose theta is an angle in standard position with terminal arm in quadrant 3, and tan theta equals 1 over 5. Determine of sine and cos. It's in quadrant 3. So C-A-S-T. We're in this one here, so sine and cos are negative. We also have that tan theta equals 1 over 5, and we know that tan is over adjacent. Then I can draw my angle. I know it's in quadrant 3, and the opposite side is 1. The adjacent side is 5. So something like this would give us 1 and 5. But because it's in quadrant 3, that's a negative x value and also a negative y value. For cos and sine, we need the hypotenuse. So let's find that using Pythagorean theorem. A squared plus b squared equals c squared. Negative 1 squared plus negative 5 squared equals hypotenuse squared. 1 plus 25 equals hypotenuse squared. 26 equals the hypotenuse squared, and then square root both sides. H equals of 26. And then can we simplify square root of 26? Perfect square numbers are 4, 9, 16, 25, etc. We want to find the biggest perfect square that can divide 26. It couldn't be more than 13 because that's half of 36, so our options are 9 and 4. 26 divided by 9 is a decimal, and 26 divided by 4. Square root 26 cannot be simplified. So our hypotenuse is square root 26. Our reference angle, theta r, is in here, and our angle, theta, is here. Now we can do the exact values of sine and cos. Sine of theta equals opposite over hypotenuse, which is negative 1 over square root 26. And cos theta equals adjacent over hypotenuse, which is negative 5 over square root 26. Solving trigonometric equations. Solve sine theta equals negative 1 over root 2 for theta greater than or equal to 0, less than or equal to 360 degrees. We need to look at a few different things here. We have that sine theta is negative. So using the cast rule, C-A-S-T, if sine is negative, then that tells us that our terminal arm is either in quadrant 3 or in quadrant 4. Those are the places where sine is negative. The other two quadrants, sine is positive. So we have more than one possible solution here. Then we need to look at what sine equals. Sine is opposite over hypotenuse. So if sine is 1 over root 2, then the opposite side equals 1, and the hypotenuse equals the square root of 2. So then we need to think about which special triangle these numbers are from. We have a square root 2 in the 45, 45, 90 special triangle. Let's draw that triangle. Our two leg lengths are 1, 90 degrees, 45, 45, and hypotenuse is the square root of 2. So this tells us that the reference angle for our angle in this question is 45. Opposite hypotenuse, sine theta equals 1 over root 2 has a reference angle of 45. And it's in quadrant 3 or quadrant 4 because sine is negative. So we can draw the two possible situations. We've got a negative 1 for the y value, negative 1 for the x value in quadrant 3. We've got a reference angle of 45 degrees and hypotenuse square root 2. And then our angle from standard position would be this. So how do we find theta? We add 180, because we know the negative x-axis is 180 degrees. We add that plus the reference angle. So theta equals 180 degrees plus 45 degrees, theta 125 degrees. There's also the option that the terminal arm of our angle is in quadrant 4. Let's draw that possibility. Our y value is negative 1. Our x value here would be positive 1. Our hypotenuse is still square root 2. Our reference angle is 45 degrees. And then our angle in standard position is there, theta. How do we find this angle? All the way around our x-axis is 360 degrees. So our angle theta plus 45 equals 360. So if we want to find our angle theta, then we take 360 degrees and we subtract 45 degrees, which gives us 315 degrees. Solve cos theta equals -1 over square root 2 for theta between 0 degrees and 360 degrees. Same exact process. First, we want to use the cast rule to decide what our angle can be. Cos is negative, so quadrant 2 or quadrant 3. Then we want to think of our special triangles from cos equals -1 over root 2. The adjacent side equals 1 and the hypotenuse equals square root 2. Which special triangle has 1 and root 2 for side lengths? Again, that's our 45, 90 special triangle. Draw the special triangle. Side lengths 1, hypotenuse root 2, 90 degrees, 45 degrees, 45 degrees. Cos 1 over root 2. With this special triangle, our theta r is always going to end up being 45 degrees. So theta r equals 45 degrees. And in quadrants 2 or 3. So let's draw the two possibilities. Here's the possible solution in quadrant 2. We have side lengths y would be +1, x would be -1 in this quadrant, and then square root 2. Our reference angle is 45, and then theta is here. To find theta when we have an angle in quadrant 2, we start with 180 degrees, and then we would subtract the reference angle to get what's left, which would be theta. That gives us 135 degrees. The other situation is if our terminal arm of our angle is in quadrant 3. Which looks like this. Then our y value would be -1. Our x value would also be -1. And our hypotenuse is still square root 2. Our reference angle is 45. Our angle. To solve for theta this time, we know that the negative x-axis is 180 degrees. We want to add that plus our reference angle. So theta equals 180 degrees plus 45 degrees, 225 degrees. Solve cos theta equals 0.8090 for theta greater than or equal to 0, less than or equal to 360. Let's look at the cast rule again. We have cos is positive. Which means our angle, terminal arm of our angle is going to have to be in quadrant 1 or in quadrant 4. Then looking at what cos theta equals, 0.8090, it's not a special ratio that would come from one of our special triangles. So we're actually going to have to use our calculator. Thinking back to Math 10C, when we solved for an angle and we knew cos of that angle, then we did theta equals cos inverse of the value of cos theta, 0.8090. Bringing up our calculator. Second cos gives me cos inverse, then 0.8090, enter, and we get 36.0016, so we'll round that to 36 degrees. But this is our reference angle, is 36 degrees, and we know that our answers are going to be in quadrant 1 and also in quadrant 4. So we can draw those situations. The first one, if our angle is in quadrant 1, 36 degrees, we'll say it's about here. And that's theta r, but in this case,